Hi friends, welcome to the channel. This series will be very helpful for those preparing for the LEED Green Associate exam. If you are registered for your exam, I highly recommend you go through the entire series. It will provide you with valuable insights and guidance. Each questions and answer option will be explained in detail, making it easier for you to understand every aspect of the question. By the end of the series, you will have a clear understanding of the exam format and the type of questions you might encounter. So please support the channel by subscribing and watching the videos. Your support means a lot. So this will be the teaching format or guiding approach for our series, which is an example of regenerative design. In the LEED Green Associate exam, you will also be presented with multiple choice questions with 4 options. However, for now I will eliminate the options and focus solely on raising the question. Then I will provide a detailed summary. For instance, let's start with the question, what is regenerative design? This is how we will conduct our LEED Green Associate exam series. Regenerative design. Regenerative design is an important aspect to mention that can be seen to be one step ahead of sustainable design. It is a type of building design that creates no waste and provides more output than the consumed input. As regenerative design projects do not use any more energy than they produce, so they won't use more than that they produce. Projects that only use their own generated renewable energy are called net zero energy project. Okay, I hope this is very clear. USGBC predicts green buildings and communities will create regenerative projects that will 1. Support the health of the local community and regional ecosystems. Number 2. Generate electricity and send back to the grid that we have discussed in the previous slide. So they produce the electricity and they don't use more than that they produce. So the remaining will send back to the grid. Then return water to the hydrologic system cleaner than it was before use. So no pollution, no water pollution. Then serve as location for food production and community networking. Then regenerate biodiversity. Finally, promote many other relationships that link projects to the whole system of life around them. The 5 key principles in designing regenerative buildings are 1. Ecosystem-centric design, social well-being design, 3. Prosperity-oriented design, then circular economy design, then disassembly-driven design. So the first principle is ecosystem-centric design. To implement ecosystem-centric design, we must recognize the interconnectedness of living systems and aim to enhance the ecological health by integrating natural elements and processes. Social well-being design. To achieve regenerative design, we should implement design for social well-being that is not only oriented to individuals and building occupants but also enhances the social interactions and diverse need. To implement the principle, the designer should add opportunities for social interaction to the surrounding area, community, and also city to foster the community cohesion and inclusivity. So the third one is prosperity-oriented design. Regenerative buildings encourage businesses to invest in the community, create jobs and foster economic growth with a focus on the growth of the existing local economy and quality of life. For instance, sustainable practices within the construction projects can lead to increased local spending, local businesses and job opportunities. The fourth one is circular economy design. The goal is to enable materials to flow in a continuous loop without generating waste or to naturally break down over time. In this framework, bio-based materials emerge as a primary option for regenerative design. So the final one is disassembly-driven design. This principle emphasizes creating products and structures that can be easily disassembled at the end of their life cycle. By designing for disassembly, we enable efficient recycling, repair, and reuse of components. Imagine like buildings where individual parts and can be separated without causing the damage. I hope the first part regarding the regenerative design is clear for you. Then we will jump to the next question. Scope 1, 2 and 3 emissions or Scope 1, 2 and 3 energy. These terms might surprise you, but they are quite simple. In your LEED GA or AP exam, you may encounter questions asking you to identify which emissions belong to Scope 1, 2 or 3. That's why I have provided this explanation. Once you understand what scope 1, 2 and 3 mean, you can relate them to the answers. This knowledge will help you easily identify and answer question in this category correctly. Scope 1, 2 and 3 emissions are categories the greenhouse gas protocol uses to classify emissions based on their origin. These categories help companies understand their environmental footprint and set reduction targets to contribute to climate change mitigation. Scope 1 emission. Direct emission that a company owns or controls, such as burning fuel in company vehicles, heating oil or equipment. Then Scope 2 emission. Scope 2 emissions are indirect emissions from purchased energy, such as electricity, steam heating and cooling. Scope 3, that is happening outside the company. Let's see this. Indirect emissions that occurs outside of a company wall and are controlled by other parties such as utilities doing transmission and distribution. Always, Scope 3 emission can include a wide range of activities and account for more carbon emission than Scope 1 and 2 combined. For example, the energy generated on site through burning of fossil fuel will fall under Scope 1 energy and the resulting greenhouse gas emissions will be classified as Scope 1 emissions. Then the electricity bought from the utility company will be classified as Scope 2 energy and the resulting greenhouse gas emission will be Scope 2 emission. The energy consumed during the employee commuting and business travel will be classified as Scope 3 energy. I hope this is very clear for you. The next part is refrigerant management. Under the category energy and atmosphere, there is a prerequisite and a credit associated with refrigerant management. The prerequisite is fundamental refrigerant management and the credit is enhanced refrigerant management, and for that credit you can get 1 point. So at the end of this part you will familiarize with the prerequisite and credit and will able to answer this question. Is CFC based refrigerant management is still exist or not? As I mentioned, there is a credit and prerequisites which deals with refrigerant management. Sorry for that. So if you go to the intent for the prerequisite fundamental refrigerant management, it states that the intent is to reduce the stratospheric ozone depletion, which means CFC. So chlorofluorocarbon, we all know that it is a major contributor of ozone depletion. We are not supposed to use CFC based refrigerant in new heating, ventilating and air conditioning and refrigeration, that is HVAC and R system. Another case, if you are using the existing HVAC and R equipment, we need to do one thing: complete a comprehensive CFC phase out conversion before project completion. So the term before project completion is very important, not after 2 months or 3 months, just before the project completion. Next case, if you are using existing small HVAC and R units, also defined as containing less than 0.5 pounds, that is equal to 225 grams of refrigerant, and other equipment such as standard refrigerants, small water coolers, and any other equipment that contain less than 0.5 pounds or 225 grams of refrigerant are exempted. So these 3 points comes under the first prerequisite, fundamental refrigerant management, and the next point comes under the credit, that is enhanced refrigerant management. So it suggests that do not use refrigerant or use only refrigerants that are naturally occurring or synthetic that have an ozone depletion potential, also abbreviated as ODP, of 0. So no ozone depletion, and global warming potential of less than 50. So 0 for ODP and GWP less than 50 is must. In short, we are not supposed to use CFC based refrigerant in new HVAC and R system. If we are using the existing HVAC and R system, we need to do a complete CFC phase out conversion before the project completion. And if you are using existing small HVAC and R unit, we can, like there is an exception, we can use less than 0.5 pound, that is 225 grams of refrigerant. And the next point is we are only supposed to use naturally occurring or synthetic refrigerant that have ozone depletion potential, ODP 0 or GWP less than 50.